Hello again, everyone. This is Mark from Avalaunch. Today we are joined again by Cengiz, the co-founder and CTO of Dexalot. And we are also joined by Ilker, who is the technical lead at Dexalot. And I wanted to get everyone together here to kind of cover some of the more technical aspects of the project. And today we're going to be going over a pretty detailed explanation of the architecture of everything that's happening and kind of all of the pieces that come together to make Dexalot possible. I think it's a really, really important thing to dive into and understand, even if it is very technical at points, because I think it's good information to be out there. And I also think it's important for people to realize just kind of how hard this stuff is. It's easy to sort of look at the project and take it for granted. Be like, there it is. This is great. But there's a lot happening here, and I think it's important for people to attempt to understand it. So, Ilker, really great to have you here to kind of take us through some of this stuff. I know you guys have a presentation prepared, so I'm just going to kind of get out of the way and see where we land. But really nice to have you guys here, and looking forward to learning more. So we're just going to kind of pull this up here and let you take it away.
All right, great. Thank you very much, Mark. And please feel free to ask any questions while we're going through this, because it's better that it's two-sided discussion. We might be assuming that we talked about something, but those assumptions are usually wrong. So it's always better that if you guide us a little bit.
Yep, sure.
Okay, so we have two slides. The first one is the simplified, the one that you're seeing, and then we're going to do a deeper dive and show you the complicated and detailed one. So basically, when you look at many blockchain projects, and Mark, correct me if I'm wrong, the two elements show that this browser in this, and the users on the left, obviously, and the blockchain. That's usually, as far as my perception is, this usually what the interaction is about, and there are not really that much needs for additional components that are running in the backend. I mean, you might have an indexer, or you might use a third party for that. And then you can receive the data in that way, perhaps. But I guess you don't really need more than that.
Yeah.
But for a club, we needed a lot more than that,
Right.
because it's a different ball game. So, like traditionally, we have the browser, and technically, this from the browser you can trade, and you get your executions. You are pretty much kind of self-sustained with those two components. But all the nice bells and whistles, like the charts or some stats or the order book, and aggregation of an order book that Ilker put in not too long ago, that it's not in production yet. And there are all these different things that we keep adding. And that's being made possible with all the backend components in the backend that you don't see. So in a simplified way, the core component of the backend is the database, right? This AWS PostgreSDB server, where we have we index everything, we cache everything in the database that we listen from the Avalaunch C chain, right? So we have a middle component, we call it writer. In this middle component, it just listens to order events, execution events, some other things, and all it does is drop copies them to the database. We also have this reader component, what we call it, the reader in a way. We should find better names.
Obviously, yeah.
Reader is like so. It's actually in big corporations. I'm just changing the subject a little bit. Like JP Morgan, the first thing that when there was a project, the first thing that people did to give them a great name. Like amazing name. This way, it's a sales job. Even
Oh
inside the
yeah.
big corporation, it's a sales job. You have to present your product, and it starts with the name. For
Uh
us, it was just the functionality, not the name. What does this do? It writes to DB. The other one, it that's it. So
Yeah,
Yeah,
it's got to
sometimes
be.
simple is the better.
Yeah, yeah. Well, in crypto, it's got to be sexy. It should be called
yeah, it
like
Exactly.
has to be sexy. Well,
uh,
yeah,
Project Caesar or something.
yeah, exactly. So we'll take that as we table that item, and then we'll find better
Sure.
names for our components. Um, so yeah, the reader is basically all it does uh, is servicing the data that it gets from the writer or the database. It services them to the client's browser. So if the client wants, hey, what are my historical data, historical orders? One option is to go to the C chain, right? Query the orders one at a time in real time. Or the other option is you send a request to the backend, which is in this case for the orders at a REST API call. You send a request to the backend. Backend goes to the database and retrieves the orders for that trader and returns it back to the browser. That's one flow. Uh, what is the other flow? Different. Like you can get your executions, you can get some other things, but what's missing? That this is a one-way communication, right? If the user requests it, the server returns it. Now we have a different component as well, which is two-way communication, what we call as WebSocket, where we can push information from the server side to the front end. So we use that, use WebSockets for that. Why do we need WebSockets? Right? You might ask. Obviously, charts for one.
Mhm.
Charts are changing every minute, every 5 minutes, whatever, or order book. Order book is changing, or the trade history, that's changing.
Mhm.
So you can have a solution as the client clicking a button to show the charts at that point in time with this REST API call, or you can make the browser as a passive instrument and just listening to what's going on in the server side, right? So
Right.
basically, the reader is seeing everything that's going on in the backend, the orders coming, executions happening, candle charts are being built, and so forth. And as it sees, it sends the data back to the browser. So the browser is always, you see something happening without having to click in the buttons.
Mhm.
So in a high level, that is the architecture. So this is the part that, in a way, I built this, and then Ilker came along. Ilker came along afterwards, and I said, "Look, Ilker, we need to make this a lot better, like a professional." I mean, this was before we went into production, obviously.
Yeah.
And I was like, we need to make this so much better that we can have support lots of users. And I had all this everything in my mind how it should have been, because I said it in our other interviews. I built many trading systems before in Wall Street, and there is a classical design pattern that everybody uses. It's not rocket science in that sense,
Yeah.
architectural. So you have all these things that we're going to talk about that professional shops are using. So we wanted to replicate this in
Okay.
our.
Now, before we move on, I have a question. When you're talking about having designed trading systems for Wall Street, like what for someone like what does that mean? How much do these vary over time? Why does a trading system need to be redesigned? Is it just like contextualize that some? Like, what does that actually mean?
Okay. Usually, trading systems are being redesigned in Wall Street for different shops. It's when the previous system hits a capacity constraint or feature constraint. Usually capacity, because especially in equities, there was so much increase in electronic trading when I was in JP Morgan. And so as a result, um, people had to bring in a better system that had the capacity as well as the new features that is installed together and build it from scratch. And also, there is also another aspect to it. For example, shops, they sometimes they let's say they steal a whole business group from another bank. So that and not the other bank, when the business group, let's say program trading, which is one of the things that I built for JP Morgan, one of the infrastructures. Program trading business, it's basically um, an equities trading, but when institutional clients want to send thousands of orders for different names at the same time, they don't just say, here's 1,000 IBM, trade this for me. They're sending a basket of stocks up to, like, a few thousands, and they say, here is my basket, trade this for me.
Mm-hmm.
And that can only be traded electronically, right? There's no other way that you can do, like in an OTC fashion, or try to go and trade it in manually,
Right.
basically. So in that case, there was a group that came from Morgan Stanley, and they said, you know what, this is not going to work because we need this features in our trading system. We can provide better services for our clients, and we need much more capacity. So that was one. The other trading areas that requires, like, another job that I held was statistical arbitrage trading. So that's a kind of black box of trading. Uh, we built our own algorithms, and we built our own models as well as trading systems in a black box manner, and we
Yeah.
would trade them. We would use the bank's infrastructure, but the coding as well as the algorithms belong to us.
Mm-hmm. Mm-hmm.
So, and we had to keep changing it ourselves
Right.
over and over. So in that, I built like an FX system, an option system, this, that. So does that answer your question in general?
Yeah, it
Or
does. I just think it's interesting background. And is thinking about these systems in this way, was that useful with designing something obviously like this, but like I wonder about like Dexalot discovery, sort of the process, right, of what needs to happen and the things you need to watch out for. And like, was the design of this informed by your past work in Wall Street and outside of crypto?
yeah, I mean, it definitely helps a lot. I mean, even if it wasn't, like, there's a saying, uh, the first time you build something, you make a bunch of mistakes. The second time you get better, third time, fourth time, and then you get proficient at it, right? So
Yeah.
same thing with applications. Like, after building so many trading systems for different reasons, uh, you kind of an idea of what's the most flexible way
Right.
to build something, and you don't try to build something like the best system, let's call it, out there, technology wise, this
Yeah.
from the start. You build it in a manner that is good enough for the requirements at that time, keeping in mind that you will evolve it to make it much better if circumstances change, which they will change. So having this infrastructure built as this, it really helped for Dexalot discovery.
Yeah.
It was like, in a way, after we changed the contracts from the blockchain side,
Yeah.
the rest is just fell into place because we have the order book. We have the WebSocket that is pushing the order book to the clients. We just implemented a quick algorithm in the backend to show what's the potential match, and the how it is if we were to close the Dexalot discovery at that point in time, how many of the orders would match, what's the quantity, what will be the price, potential price, and the bounds, and so forth. Uh, yeah, to answer that question, definitely it was like, and to tell you the truth, uh, Dexalot Discovery, I mean, I did a lot of the coding on that.
Uh huh.
It took us about 20-25 days.
Yeah. Yeah. No, I remember. I remember.
Yeah.
It's very, very, very impressive.
So yeah, okay. So yeah, I had this in the summer, and Ilker started with us in the summer around August, and I told him about my ideas. I said, we need this nice uh, message bus in the backend. Like we need an in-memory database just to make this add some speed. And Ilker was like, wow, yeah, okay, these are great ideas. And then he took them and then he just implemented. So let me go to the next slide. Not
Mhm.
the next one, I
And one
guess.
thing I want to make sure that we cover here, in well, not here, but I'm assuming it's in the more detailed one as well. Are the market maker bots, and so how those work, why it's necessary, and the challenges contained within those.
Okay. So,
But whenever that's appropriate.
okay. Uh, Let me give the a chance to Ilker to talk. Maybe Ilker, if you could
Yeah.
explain what we did with Redis, PubSub,
Sure.
and the how do we put the Node.js readers and writers in
Yeah.
what context? If you want to.
Yeah, sure. Thanks, Cengiz. So, like in the initial version of our app, like before we went live, we did like obviously some load testing, and like it was obvious that we needed to like scale better using the writer and the reader modules. We have like low number of writers because like clients don't directly interact with them; they
Mm-hmm.
interact with the readers. And as the number of users grow, we are automatically like increasing scaling the readers. So looking at that perspective, we had to optimize like the data access for those readers. And for that, we like switched some of, as Cengiz mentioned, we are both utilizing REST API requests, which is like per request basis, serving client requests from browsers. And for the streaming data, it makes more sense to use WebSockets, right? It's more optimized. You don't have the like some overheads. So that we moved some of our REST API calls to WebSocket calls, which
Mm-hmm.
like increased our capacity to serve more many users. But the like crucial part was utilizing the caching. For that, we are currently using like AWS Elasticache, which under the hood uses Redis. Redis has like two main functionalities. You can use it as a like standard caching mechanism, so key value store, and also it provides us like a streaming pub and publish and subscribe mechanism, which is like really useful in this use case. So what we do is writer gets all the events from the blockchain, and then it pushes those events to PubSub queues and
Mm-hmm.
topics, let's say, and readers are all listening those topics. Then, as we like increase the number of readers, then it's already like scaled. Clients connect to readers and fetch these streaming data and process them on their front end. It can be like candle data, it can be users like trades and so on. So in that sense, it increased our capacity a lot, like utilizing this caching mechanism. And like another thing we did was as like the team gets team number of like engineers in the team gets larger, we needed to have some like automation for deployment and build procedures. And for those, we are like utilizing AWS services, which is like code pipeline and code build services.
Mm-hmm.
Which main what it mainly does is when we like push our code to our repository, it automatically like fetches the code, builds it, like runs our tests to verify if it's working correctly and nothing is broken. and after that, like it builds and deploys it automatically to dev environment. And obviously we need some manual like approvals for pushing to like our Fuji network and like production. But this eliminates like the like human component like errors which might happen in between.
Okay.
Yeah, Cengiz, I think these are
Yeah,
like the yeah, let me hand it over to you.
yeah. So these readers, we also have what we call the subscription managers in the readers component, meaning they the clients they are subscribing a certain things via WebSocket, and the readers are actually servicing them based on their subscription models. What could they like? Which market, which pair they are listening to the chart data or the history. They click another pair, so that changes, right? So that's the subscription manager in the reader is saying, oh, okay, this client now is listening to this pair charts, and it's also listening to 5 minute charts, not the 10 minute, and also listening to the order book. But the order book now, as of last week, order book now has an aggregation feature where you can say, like in the sexes, right? You
Yeah.
can click on the four zeros or three digits, two digits, like you can aggregate. So those are all done by the reader subscription manager.
Hmm. Okay.
Um, then yeah, Redis, PubSub, and uh, for the writer, for example, now the Dexalot discovery algo, which is doing the theoretical matching where the
Yeah.
price would be and so forth, that is computationally expensive. Like we cannot do that in the blockchain constantly. So the writer is actually calculating that as the order book changes, it calculates, and it's just a indicative. It sends the data, indicative data, to Redis, to the PubSub
Hmm.
Y. It sends it there, and all the readers, just like a text message, think of it. So
Yeah.
the writer sends a text message to a group, and all the readers gets the message, and then they say, "Where are my clients?" Which are the browsers, the client browsers. They in turn forwards the text message to all of their clients. So there is like a uh, one to many, one to
Yeah.
many, the many to many
Right.
uh,
Right. Right.
algorithm there. Um, yeah. What else can I talk about? I mean, I can get into the market maker bots now.
Yeah, I want to talk about that. And I also want to ask, in looking at this, one of the things that stands out to me as worth exploring are the centralized versus decentralized components of this. And so, it's an interesting conversation, right? Because when you look at the value proposition of decentralized finance, Dexalot, so much of it is around, taking control back. And so naturally, there's this conversation that like presents itself around uh, the decentralization and the spectrum and sort of what lands where and why it's important and why it isn't relative to what's available and what's not, and how you maintain like the integrity of the decentralized component and value proposition while still delivering something that a user is going to expect. And it's a real hard problem. And I think
Yes.
depending on the team, right, you're going to land on different types of trade-offs. Obviously, some of these things are givens, and then there's decisions that can be made around what and why and when, right? And so I
Mhm.
kind of want to understand, it's a pretty broad question, but I want to understand like how you guys think about this. Like obviously you have, AWS, and you have more
Mhm.
typical web application stuff that is centralized. And this is not unique to you guys in any regard, right?
Correct.
It would be true of any DEX or any web application, even the most decentralized ones. And so I just kind of want to start to poke and understand at your guys' thinking around this, and how you look at the trade offs, or if you look at them as trade offs, and just kind of explore that.
Sure. I mean, that's a great question because, yeah, people will ask, you have so many backend components and they're all in AWS, right?
Yeah.
Is this decentralized enough? Well, the key part I want to make the distinction is that the users, via their MetaMask, they are talking to the blockchain. So I want to emphasize this really, like they send an order to blockchain, they cancel their order in the blockchain. If they get a match, that's from the blockchain. All
Yeah.
right. And that's the extent of it. If they do participate in Dexalot discovery, it goes in the blockchain. In short, everything is on chain. So these two components, the users, browsers, and the blockchain, is the fundamental decentralized area where everything's happening. All the rest is bells and whistles because we want to give the users the experience so that they see, okay, they're used to seeing a um, chart. Okay, how can we do that? We just have to read from the blockchain,
Right.
you know, put the data together, and then send them in a different way. What happens if everything that went down in all these backends, like our database went down, our writers and readers, they all went down. Everything's in the blockchain.
Right.
Yeah.
You can
No funds are
still
lost.
get your assets. Like it's very
Yeah,
unlike, Binance shuts down. It's like you're just out of luck. You still have
exactly.
access and ownership of these assets.
Exactly. You can actually go to Snowtrace, and from the Snowtrace, you can withdraw your money from the Dexalot portfolio. You don't
Right.
even need our front end.
Yeah,
So,
theoretically, you can invoke any like contract yourself.
yeah,
It's just like putting these as convenience for the end user.
yeah.
Mm-hmm. Mm-hmm.
So, but it doesn't mean that we don't have crash recovery or hot swaps or all kinds of, like, every methodology that's being used in centralized systems. Like, for example, our database is replicated real time in another AWS region. So if one instance of our database goes down, we can quickly hot swap it to the other database, and everything will be there as well.
Right. Right.
Our writer, it crashes. Let's say it will recover where it's left off. We have crash recovery mechanisms. We know what's the last message the writer processed from the blockchain, and it knows the block number, and it will continue from that block number to process the messages and put it in the database.
Mm-hmm.
Our readers are load balanced, so some of them go down. They will be automatically spawned, and if we have 100,000 users, then we will have, let's say we had like 10 instances of the readers for 10,000 users. And if we had
Mm-hmm.
10 times as much, then the readers new instances will be spawning on their own. We don't even have to go manually do anything.
Mm-hmm.
So same thing with our Redis. It has a hot swap. If it goes down, again, there's um,
A cluster mechanism.
diversion, a clustered. So we made sure that we have backups in many different ways.
Yeah.
Historical backups of the database, crash recovery, failovers, all these things, it's built in, and we made sure that they are there. So
Yeah.
the end result is we want to make sure that the user experience is not disturbed
Yeah.
by
Yeah.
having this additional things.
Yeah, I mean, as a user, to me, that satisfies everything I would be looking for with respect to a decentralized exchange. I can access my money, I can access my trades. To me, this is my opinion. It doesn't matter to me that the charts and the candlesticks are served to me on chain. Like, why would it? At
Mhm.
the end of the day, it's not. I'm not going to find myself in a situation where I'm on a centralized exchange, and they are telling me, well, you guess what? You've withdrawn enough money today, or you got to come back tomorrow, or you haven't given us enough information to withdraw this. Let us know when you want to give us that. That kind of stuff. To me, that is the progress. That's the step forward in the experience around these things. Being, let's say, centralized or existing elsewhere. To me, as a user, and I care a lot about this stuff, it's irrelevant because I know where the technology is, right? And so you can't. It doesn't really serve you, I think, to be irrationally principled about this, right? Because you're just going to sacrifice the entire
Oh
thing
yeah.
altogether, right?
And from a speed perspective, there is no way that we can process, let's say, the chart data from the blockchain and
Right.
service it in time. It's
Right.
it's it's kind of counterintuitive. And do you make any real trading decisions if your chart data is from the blockchain versus right?
No.
Not really. It's just like you make
No.
a decision based on the different factors.
Yeah.
So
No. I mean, nice in theory, but sort of largely irrelevant.
yeah,
Okay. Yeah. Let's talk about the market maker bots, and what these are and what purpose they serve. And again, just help people understand how they work, and the challenges, the technical challenges in making them work and do what you need them to do.
yeah. So this market making bots basically it took me back to my Stadart trading desk times because that's exactly what I did. Not market making wise, but prop trading, what we called it, uh, writing algos to you know capture some alpha from the market. So in this case, when I was writing the market making bots, I was in a different environment. Uh, for any high frequency trading strategy, the first thing, which market making is a high frequency trading strategy at the end of the day, the first thing you look at is the transaction cost. So the bigger challenge was having to pay for gas for every transaction. How is it going to impact the P&L at the end of the day? So when I was writing the market making bots, that's what I had to keep it in mind. And I had to keep in mind about the gas price system, like gas price hikes. That is the Avalanche chain sometimes gets busy, and the
Hmm.
gas prices are higher. So you have to adjust your algorithm based on that as well. Maybe slow down trading a little bit
Yeah.
instead of, or uh, make your spreads a little wider. This way, you don't have to send as many orders and pay the gas on so forth. So that was the biggest challenge. It basically uses the same components as our other ones, like it gets the data from our Redis. It can tap into the database if it needs to, and then the private keys obviously in is embedded into the bots, so it can directly send to the chain without clicking MetaMask approvals.
Hmm.
Now, why am I saying that? Because we're going to like as in addition to professional market makers that are coming,
Yeah.
and we're working with some of them currently. They're implementing their own market make algorithms that they can send market make in Dexalot.
Yeah.
Uh, we also want to open a code base, a sample bot code, so anybody can write their own bots, whether they are arbitrage strategies or they can be market making strategies and so forth. And they can basically interact with the chain directly, and they can get additional information just like they were a browser. They can send uh, they can use our REST API to receive some data. And also, we're going to open the WebSocket to them as well
Hmm.
eventually.
Hmm.
Um, Now, once we are in the subnet, maybe we can talk about the ECAN. ECAN has been work doing a lot of work in that
Yeah,
front.
let's do it.
Once we go in the subnet, we can control the gas much better.
Uh-huh.
And this way, the transaction cost is not going to be a deterrent, let's call it, for high frequency traders.
Mm-hmm.
Ilker, do you want to say anything about the subnet,
Subnet part.
uh,
Yeah, yeah. So for
the
subnets,
challenges that we are facing, that we're
mhm.
talking about, that we want to solve? Yeah.
Yeah, yeah. So we are working very closely with the Avalanche team, like Avalabs, for subnet implementation. We are exploring like different options. Like we obviously have to make some trade-offs between them. We want to like release quickly, so time-wise, we have like different plans for the long term and the short term.
Mm-hmm.
But obviously, it will be like pretty useful for gas prices, which is like the main problem currently. Yeah.
Yeah.
So, like one thing that we're talking about is native precompiles.
Mhm.
So, for the subnet strategy, I think we're going to have two or three phases. The first phase is to replicate everything we have in the mainnet in the subnet without any changes.
Mm-hmm.
And because we're going to be using our a lot token as the gas token,
Mm-hmm.
automatically the gas prices, and I mean, it's not going to be AVAX anymore, so that will decrease the price.
Mhm.
And because it's a subnet, it's not going to be as busy time to time. We are expecting to be not as busy as the main net, so that we can control the gas price in two
Right.
ways.
Right.
And the second phase is going to be implementing native precompiles. What they are for a everyday user, native precompiles is actually, think of it as a bunch of code that executes, but we can say no matter how many executions, like not executions,
Instructions.
yeah, yeah, how many functions it does, like how it doesn't matter if it takes 10 seconds or 20 seconds or whatever, it's going to cost this much gas,
Yeah.
and that's it. It doesn't.
Yeah.
So it's kind of making it static. So every order, what does that mean? Every order is going to cost, let's say, 200 gwei. Just made up that number. Okay.
Mm-hmm. Mm-hmm.
So that's might be like, then everybody knows, like, it doesn't matter if the system is that busy or not. It doesn't
Yeah.
matter what the gas price is. If there's a small variations, it's not going to matter because it's going to be low enough that it's not going to make that much of a difference.
Right. Interesting. Yeah, I had a conversation last week with Lucian on the at Ava Labs about subnets and Dexalot and sort of what some of the teams are doing there. And yeah, shout out to Lucian. I think he has a maybe in the running for the nicest guy in crypto. Right behind the Dexalot team. So, but what
You are by far the nicest that we met.
well, yeah, we just be a bunch of
Trust
a
me,
family of nice guys, right? That's we need more of that in crypto. That's for sure. Um, I'm just trying to think about the how to kind of to phrase this question because you guys are at an interesting point in time in that you built this application which is possible on Avalanche, but really optimized for a subnet. The subnets kind of aren't here quite yet, but they're close enough. And so you have this interesting problem, which is how do we design this in a way to be impactful for the C chain, but also planning ahead to really sort of realize the full vision on the subnet. And so the question in here is how much does this design rely upon the C chain, and would it be very very different if just say we were 2 years from now and subnets, the promise of subnets had been realized and we're all living in a subnet world? How different would this be? And furthermore, what does the transition look like?
okay. This different meaning, this architecture.
Yeah, like
Okay.
yeah, the
So
architecture.
from the architecture point of view, we will just take this Avalanche C node C chain
Mm-hmm.
and replace it with the subnet. That
Yeah.
will be that, and it will be a configuration change. To tell you the truth, that's the very first implementation, which there when there is no changes whatsoever, meaning the before native precompiles. The It's just that from technical perspective. Now there are other aspects of subnet, like how do we transfer assets between the mainnet and subnet. That's I'm putting that on the side. But otherwise, it's really we can be on the subnet. If the subnet was ready, we
Mm-hmm.
change the configuration, we continue trading. We deploy the
Mm-hmm.
contract, sorry. We first deploy the contracts, and then we change the configuration to point to the new contracts addresses and the subnet, and that's it. Nothing will change.
Mm-hmm.
It will be
Mm-hmm.
overnight for us. Now,
Interesting.
whatever additional things,
Mhm.
asset transfer, we can think of one challenge that every subnet, every project that wanna go in the subnet face, right? Um, that's one. Um, what else? Oh, I
Yeah.
mean, we have to have obviously we have to have enough validators to keep the decentralized fashion. So we have to incentivize the community to validate for us as well, right? Um, in a way, we will be operating start operating our own nodes for the subnet just to have a
Yeah.
bare minimum. So that adds to our infrastructure needs. That's a difference. So the transition is getting the subnet ready as is with our nodes, and then our plan to incentivize the validators from the mainnet so that they can validate for us, and then deploy our contracts and point to when everything is ready, and then we feel that it is decentralized enough that we cannot be we cannot be attacked in any way, shape, or form from a decentralization perspective,
Yeah.
and just switch it on.
Mm-hmm.
That's what, in my mind so far, that's what it looks like. Now, again, asset transfer, we have a few options. We can use bridges, or hopefully Avalanche will have some type of native implementation. That will be amazing. I know they're working on it, but they
Yeah.
cannot promise on the date. So
Right.
that seamless transfer between subnets and the mainnet, that will enhance the user experience tremendously. Instead of going to a bridge, transferring from mainnet to subnet, and if they want to withdraw, they'll have to transfer again from the subnet to the mainnet. There are some bridges, they say you can transfer from subnet to subnet, or mainnet to from your subnet to other blockchains. They're promising these, so we are evaluating them as well.
Mm-hmm.
Uh, but yeah, I mean, Ilker, do you want to add anything on?
Yeah,
Well,
that's pretty much it. Yeah, and in the long term, to optimize like gas and so on, as you talked about, like initially, we'll have to have some more like phases maybe. And in the like, as Mark asked, in the long term, after like 2 years, 5 years, maybe we will be purely like working on a Go code, and like
mhm.
it will be the ultimate goal, I guess.
Yeah,
Yeah.
ultimate, completely
Yeah, exactly.
custom virtual machine, where we
Yeah.
can maybe take the speeds to increase, like CX level speeds, and full control of the gas, so forth.
Mm-hmm. Mm-hmm.
It's a
Yeah. Very cool. Very cool. I just want to go. You guys said something about the market making bots that was interesting to me, and I just want to kind of circle back to that really quickly,
okay.
because you guys are working on your own internal market making bots, and then you have market makers who traditionally do market making on centralized exchanges, and maybe some. So the market making on dexes is on AMMs actually happens, and it's it's kind of an interesting thing itself. But so now you have market makers kind of looking at a new type of market making strategy. I think internally you guys have this position where you say we know we need these books to be liquid. We know exactly how to achieve this, and we're going to build it. Right, we're just going to get it done because the platform depends on it. And now
Yeah.
you have these other market makers, right? And I know some of the names that you guys are working with, and these are big market makers. And so, what
Sure.
have the conversations with these market makers been like around sort of this kind of like new type of industry and opportunity for market making? Like they obviously they're looking at it because they want to be involved and they want it to be profitable for them. But then it doesn't. If correct me if I'm wrong, but they've never really had to do much market making for an on-chain central limit order book. So
Yes.
how are these market makers technically approaching this new challenge, and why do you think they're interested in it?
Um, yeah, I mean, great question as well. Again, so yeah, the challenges that we faced, obviously, they are facing when they're implementing their bots as well. Transaction costs, they have to add that into their algorithms, and uh, we try to give them the as a simple integration API document, similar to CX's, right?
Yeah.
But it is, I must admit, we haven't done a good job on the document yet. Hopefully, within a month or so, we'll have a much better document. So it was more like me talking to their implementer. It's like, okay, this is what
Yeah.
you need to do, and this is
Well,
like
that's where it starts, man. Yeah.
informal. Private. Um, they are excited and they believe in this because they see that blockchain is definitely the future, but they
Yeah.
also see that a club dex is going to be excelling eventually over AMMs.
Yep.
And our plan to move to subnet, uh, they see the business model behind it, they see the technology behind it, and they believe in it. And they're in a way investing for their future in the subnet as well
Yeah.
by getting in earlier.
Yeah.
So uh, they kind of know the challenges, so they're going to have to deal with these challenges for a short period of time. But eventually, I think whoever gets in and starts market making in the club dexes,
Yeah.
probably that's only us.
Yeah.
Uh, they know there's going to be that's going to be the future.
I
I
think
believe
so.
we're going to be the future, but I believe other market makers they believe that we're going to be the future as well.
Yeah, well, I think it. Not that you necessarily need it, but I think it kind of validates the potential here. That other people see it who are like you guys. Experts have a lot of time, money invested in where the industry is going. Are paying attention to this and are already it's a priority to them to be involved even this early. And there is something to be said for being early. I look at AMMs versus centralized exchanges. We work with projects every day, and we look at this stuff closely. And this is true of Avalaunch, and this is true of a lot of other projects. Look at the blue chip projects in the ecosystem. They do, even the ones that are, let's say, listed on FTX, listed on Binance, listed on Huobi. They do the majority of their volume on AMMs, right? And this isn't an accident. Depending on who you are, there's a real reason for it. But let's say for me, it's it's easier, it's more convenient, it's native, right? And I can get it done all the same. So
Sure.
the central limit order book is certainly an improvement above and beyond that, right? So I think this is going to be huge, and we've already shown that with an AMM, which is in some ways inferior, right? Different, less efficient, not
Mhm.
as much, not as many options or features. It's still just sucking all this market share, right? So now you
Sure.
layer something tremendously more efficient on top of that and user friendly. It's like, what do you think is going to happen there? right? This is one of the reasons I'm just so excited about it. So, yeah, I think this is certainly the start of something big. Lots of people in crypto have been waiting for this for a long time.
Yeah, yeah. I mean, we are. I'm really happy to be working on a project like this because, frankly, when I left Wall Street 3 years ago, I didn't think that I was gonna work on trading systems again. I had like different plans, and I tried to get into a few other projects, but somehow, uh, somehow I find myself back into this. Right, this was like a great coincidence in a way
Yeah,
because everything that I did so far in my life, career wise, they all got together in this project from different jobs in Wall Street, different groups. They all came together. Everything that I did is like, okay, for some jobs I had to deal with databases, for example. Here you go, and I built the database. So for some other jobs, I did the algorithmic trading, the market making. So it's like all these things came together. So and uh, taking it from where you started, everybody was waiting for this, and when we something like this in for the crypto space, and when we got into it with Nihat, we realized that we could be the team to deliver it.
yeah,
So
yeah. It's awesome. Um, Well, very cool, guys. I think that's some pretty good coverage here of this stuff. I really do appreciate you taking the time to meet with me and get this out there so people can have a look and understand it. I think there's a lot of people out there that will find this really interesting and useful. So thank you again for your time. We're obviously
thank
super excited about Dexalot. Sale is starting here very soon, and and this is just the beginning.
and
Yeah.
then we'll have the Dexalot discovery in a couple of days with
Hmm.
our own token, and it's going to be amazing.
Yeah,
We can hopefully showcase the power of our infrastructure as well as the blockchain in general
yeah, hmm,
together, coming together for index lot discovery.
yeah. Well, maybe we'll do another one of these about that.
Yeah,
Um, I'm always available for it.
Great.
yeah, that will be great.
Okay. All right, guys. Well, thanks again. Enjoy the rest of your day, and we will talk soon.
All
Thank
right, great.
you.
Thank you.
Okay. Bye,
Bye.
guys.
Bye.